We talk about exoplanets a lot here on SciShow Space because they're totally awesome. Also because scientists keep finding new ones that look more and more like Earth. But we don't talk as much about what's actually on those exoplanets, mostly because no one really knows. I mean, it's hard enough just to figure out whether there's a planet light years away made of gas or solid rock, let alone if its atmosphere has oxygen in it. But sometime within the next decade, NASA plans to start a mission to look for signs of extraterrestrial life both inside and outside our solar system. On January 28th, two astrobiologists, Jocelyn Ruggiero from Johns Hopkins University and NASA's Chris McKay, held a forum online to talk about rebooting our search for extraterrestrial life. And one thing they pointed out was that if there's life out there somewhere, it probably needs two main ingredients: a source of energy and a liquid to help carry out chemical reactions. The assumption used to be that the source of energy would have to be a star and water would be the liquid medium. But as we learn more about extremophiles here on Earth, the picture of what life can look like is expanding. Extremophiles can live and even thrive under conditions we used to think would be uninhabitable, like deep-sea hydrothermal vents or incredibly salty lakes, so astrobiologists' vision of what is actually possible has shifted. Titan, for instance, has lots of liquid, but it's mostly liquid ethane. McKay has explained that there may be extremophiles that can use this liquid ethane the same way that we use water, opening up many more possible alien habitats. And since conditions on other planets can be so harsh, at least from our perspective, he said that the odds are that the first alien life that we will find will be of the extremophile sort. The pair speculated that the first mission in this search for life will probably be a probe sent to analyze the atmospheres of bodies like Saturn's moon Enceladus, which is especially promising with its jets of water vapor and ice. And both scientists agreed that the probe ought to have a kind of long-distance mass spectrometer, which would be able to detect different elements in the atmosphere. Such a probe would look for unusual elements like oxygen and ratios of substances that don't typically occur in the absence of life. Now, NASA hasn't yet decided where exactly this mission will go or what exactly it'll be looking for, but meanwhile, there's plenty of work to be done from here on Earth. When the new James Webb Space Telescope launches in 2018, astronomers will be able to get information on exoplanet atmospheres with more accuracy than ever. And if there's an exoplanet within its star's habitable zone with plenty of oxygen to go around, there could be more to it than meets the eye. In more immediate news, you may have heard about the satellite that launched last Saturday. It's called the Soil Moisture Active Passive Observatory, and it's going to be super useful for people who need to know how much water is in their soil. Which sounds maybe like a fairly small group, but it turns out to be basically anyone who cares about food, climate, the environment in general. But the rocket had another cute little payload as well: Cubesats. These twin tiny satellites are less than 16 centimeters on each side, and they are headed to the Van Allen belts to study space weather. The Van Allen radiation belts are collections of charged particles that stretch between 1,000 and 60,000 kilometers above the Earth, where they interact with the Earth's magnetosphere. And every so often, some extra powerful bursts of solar wind will send those particles, usually electrons, into a frenzy called a microburst. These solar blasts can accelerate the electrons to close to the speed of light, and all that zipping around can cause some serious problems for the computers on our spacecraft. We do our best to shield all of the electronics we send up there, of course, but when you're spending billions of dollars to send people and equipment into free fall around the planet, you really want your computers to work. So these Cubesats, together known by the wicked moniker of Firebird 2, are the second part of a mission to map when microbursts happen and how big of an area they affect. When a superfast electron hits the detectors inside the Cubesats, it'll get recorded as a data point. By plotting the points, the researchers are able to map the times and locations of the microbursts. The hope is that eventually we'll be able to predict where and when and how these microbursts happen. Then, of course, we'll be able to shield future space technology from the sun's whims, making space travel much safer. All thanks to these brave, cute little cubes. Thanks for joining me for SciShow Space News. If you want to help make all SciShow happen, check out subbable.com/SciShow, and don't forget to go to youtube.com/SciShowSpace and subscribe.